For today's video, we will answer this question from PUTNAM on the year 2018. And here's the question. Given this equation 1 over a plus 1 over b equals 3 over 2018, wherein a and b are both positive integers, then our goal in this question is to find the pairs a comma b that satisfies this equation. Now you can pause this video if you want to give this problem a try. Now suppose you pause this video. Now let's see if you got the correct answer. So we have a PUTNAM question. It says that if we're given 1 over a plus 1 over b equals 3 over 2018, then what are the values of a and b? So first, let's get this equation. And we don't want denominators, so what we're going to do is to eliminate this a, b, and 2018. So first, let's multiply all of this equation by a, then multiply this by b, then multiply this by 2018. And if we do that, we get something like 2018b plus 2018a equals 3 times a, b. Now, from here, let's rearrange some terms a little bit, and let's equate this to 0. And let's see what we got. So 0 equals 3ab minus 2018a minus 2018b. Now, in this kind of question, the technique to solve for the value of a is to factor one side of the equation. In this case, we want to factor the right-hand side of our equation. And of course, to do that, let's factor out first this a, and if we do that, we get a multiplied by 3b minus 2018. Of course, this is this result. And bring down negative 2018b. Now, let's use this result. And how do we get another factor of 3b minus 2018? Now, we have 3. So, why not? Let's multiply all of this term by 3 to have 3b. So, if we do that, we get 3a, this multiplied by 3, minus 2018b multiplied by 3. So, 2018 multiplied by 3b. And let's focus on this. Now, from here, notice this factor, 3b minus 2018. We have 3b. So, we need to have negative 2018. And in order to do that, we need to add 2018 squared on both sides. Because if we factor out negative 2018 in these two terms, we get something like negative 2018 multiplied by 3b minus 2018, which is the same thing as this factor. So let's focus on this result. And now, why not factor out the common factor 3b minus 2018? So we have 3b minus 2018 multiplied by 3a minus 2018. Therefore, the right-hand side of our equation is just 3b minus 2018 multiplied by 3a minus 2018. And notice that we have almost the same thing. The only difference is the variable. So, if we get an answer of a comma b, the other answer is also b comma a. Or simply, we can interchange the value of a and b. And also, this 2018, notice that we can factor this out as 2 times 1009. And these two are the only prime factors of 2018. Now, another observation is this 3b minus 2018 and 3a minus 2018. If we divide those numbers by 3, we get a remainder of 1. Or simply, we can say that 3b minus 2018 mod 3 equals 1. Or 3a minus 2018 mod 3 equals 1. Or simply, if we divide all of this number by 3, we get a remainder of positive 1. Now, it tells us that on the left-hand side, we want a factor, 2 factors, that is both 1 mod 3. Or if we divide those numbers by 3, we get a remainder of 1. And one of those factors is 1 and 2018 squared. Because, of course, 1, when divided by 3, we get a remainder of 1. And 2018, we know 2016 is divisible by 3. So 2018 mod 3 is 2. Then 2 squared is 4. And 4 is technically 3 mod 1. So this pair is good. Another pair is 2 squared and 1009 squared. 2 squared is 4. 4 mod 3 or 4 divided by 3 is 1 remainder 1. So 4 is simply equal to 1 mod 3. Now, how about 109? 108 is divisible by 3. So, 109 divided by 3 is 1. 1 squared is 1, so this is also 1 mod 3. And another pair, the last pair, is 2 squared times 1009 times 1009. This is also they are both 1 mod 3. Now, the question is, why not this factor, 2 times 1009 times 2 times 1009? Now, here's the reason. Because both factors are not 1 mod 3. Because 1009, we know this is 1 mod 3. 1 times 2 is 2. Therefore, 2 times 1009 is 2 mod 3. Or if we divide this number by 3, we get a remainder of 2. So, this pair or these factors are not accepted. So, we only have 3 pairs or 3 factors. We have 1 times 2018, 2 squared times 1009 squared, and 2 squared times 1009 times 1009. Now, let's start with the first pair. So, 3b minus 2018 equals 1, and 3a minus 2018 equals 2018 squared. And from here, we can now solve for the values of a and b. So, first, let's add 2018 on both sides. And this is just 2019. And 2019 is divisible by 3. If we do that, we get 673. So we found the value of B. How about A? Add 2018 on both sides. Factor out 2018. Next, 2018 plus 1 is 2019. Again, this is divisible by 3. So we have 673. So 673 times 2018, this will give us 1,358,114. So we found one pair of A, B, which is 1,358,114 and 673. Of course, if we switch the position of A and B, we also get another pair of A, B. So we found now 2 pairs of A, B that satisfies this equation. You can check that, technically speaking, those numbers satisfies this equation. Alright, now let's have the second pair, 2 squared times 1009 squared. So 3b minus 2018 equals 2 squared, and 3a minus 2018 equals 1009 squared. So let's solve for the values of a and b. So let's have b first. 2 squared is 4 plus 2018, this is 2022. Divide this by 3, this will give us 674. So this is the value of b. How about the value of a? Now, add 2018 on both sides. Now, this 2018 is 2 times 1009, so we can factor out 1009. This is just 1009 multiplied by 1009 plus 2, and if we add this, we get 1011. Now, this number is divisible by 3. If we divide this, we get 337. So, 337 times 1009, this will give us 340,033. Again, we found the third pair of A, B, and also the port 1 if we switch the position of A and B. Alright. Now, for the last one, we have this pair. So, we have 3b minus 2018 equals 2 squared times 1009, and 3a minus 2018 equals 1009. Solving for b, in this equation, we get b equals 2018, and solving for a in this equation, we get a equals 1009. So, we found the fifth pair of A, B, which is 1009, 2018, and if we switch the position, we have 2018, 1009. Therefore, we found 6 pairs of A, B that satisfies this equation. And there you have it. So, given this equation 1 over A plus 1 over B equals 3 over 2018, wherein A and B are both positive integers, then we found 6 possible values of A, B that satisfies this equation. And here they are. And as always, we are done.